Hello there, this is a geometry video. It is chapter 8, section 3, and today we're going to be talking about special right triangles. And there are two types of special right triangles, and the first one is going to be the 45, 45, 90. Basically how you get a 45, 45, 90 is you basically take the diagonal of a square. So if you can imagine this being a square, and you basically cut that square in half by using the diagonal, and you get this. We know that in a square, all of the corners are 90 degrees, so we have a 90 degree here, and when you draw in the diagonal for a square, that basically splits this other corner into two 45-degree angles, and same thing happens down here. So you end up with what we call an isosceles right triangle, because these two angles are the same. They're both 45. Those would be the base angles. And then the sides would be the same. So I've gone ahead and labeled them L for length. So here we have L and L. They'd be the same. Hence it's isosceles. And of course, the hypotenuse of a right triangle is always opposite the 90-degree angle. So we learned in the previous lesson that when you have a right triangle, you can set up Pythagorean Theorem, which basically says leg squared plus leg squared equals hypotenuse squared. So I want to show you what happens in the unique case when you have 45, 45, 90. Again, this only works, what I'm about to show you, the formula, if you will, we're going to come up with a formula, and I'm going to show you that that only applies when you have a 45, 45, 90, and that's because only in the case of a 45, 45, 90 do you have both legs being the same, which allows us to put L squared plus L squared equals H squared. So then that means that we now have two L squares equals H squared. And then when you want to solve for H, because that's what we're trying to do, we're trying to solve for H, we take the square root of that little guy, and of course the square and the square root cancels, so you get that H equals the square root of 2 times the square root of L squared. Okay, so I basically split the 2 and the L squared, so you have the square root of 2 times the square root of L squared. We know that with the square root and the square, this cancels. So really what you now have is H equals root 2 times L, or most people usually write H equals, and I want to write that in blue here because we want to have this be color coded for you. So H equals L root 2, like that. So basically there is a relationship that is specific to a 45, 45, 90 as far as the lengths of the sides are concerned. And that relationship is that you have L, L, and L root 2. This relationship will always happen when you have a 45, 45, 90. So what that means for us, we'll see in the first example here. It says find x, and they've given us a triangle. Now obviously you could, in some cases, use Pythagorean Theorem and go 6 squared plus something squared equals x squared, and you could find it out that way. But the idea here is to actually use the formulas. And so first and foremost, you want to make sure that you're actually dealing with the 45, 45, 90 before you try to apply the formula. So I notice that this is a 45-degree angle, that's a 90-degree angle, and since we know that all of the angles in a triangle have to add up to 180, that forces this angle to be 45, which makes this an isosceles triangle, and an isosceles right triangle, which makes it a 45, 45, 90. So that means that both legs are the same. So I'm going to go ahead, and if this leg is 6, then so is this leg. And so that means that L equals 6. And if L equals 6, then X is equal to the hypotenuse, and the hypotenuse would equal L root 2, or 6 root 2. And just like that, you have your answer, that the answer for X is equal to 6 root 2. It's not very complicated when you're using the formula. So in part B, same thing. The first thing you want to do is make sure that you're dealing with the 45, 45, 90. And the reason why we know that that's the case in part B is because both the legs have the same length, they're the same measure, they're both 9√2. You have a right angle, therefore this is an isosceles triangle, and therefore it's isosceles right triangle, so it's again going to force this to be a 45, 45, 90. Once we've established it's a 45, 45, 90, we see that the legs are 9√2. The hypotenuse is supposed to be sorry, I'm trying to find my eraser here. I had a little brain fart there. I want to use blue because that's what we've been using in the past. The hypotenuse is supposed to equal L √2. But we know that in this case, L is 9√2 from right here. L is 9√2. So we're going to replace the L with 9√2, but then we still have the √2 from here, if that makes sense. So the 9√2 replaces the L, but we still have a √2 here. So now you have H equals 9√2 times √2. Or in other words, X, which happens to be the hypotenuse in this diagram, is equal to 9 times √2 squared. Because √2 times √2 is √2 squared. And lucky for us, the √2 squared cancels, and then you get 9 times just 2, because the square root cancels with the square. So in the end, you get that X equals 18. So be careful with how you apply the formula. You have to make sure that you are doing it correctly. All right, so we get X equals 18. So we're going to give you a chance to try that in our next do-it-yourself question here. You have 3 opportunities to figure how to apply the 45, 45, 90. All right, and so now we have another one. And in this case, we're still going to apply the 45, 45, 90 because we can tell, even though we don't know what the legs are, we know that they're both X. So that's the same variable for both legs, which means that they have the same length. So again, that makes this triangle isosceles. The right angle here indicates that it's an isosceles right triangle, and therefore 45, 45, 90. And so X we know equals L, the length, right? And we know that the hypotenuse is L √2, and in this case, the hypotenuse is actually equal to 12. So what I'm trying to do is write an equation that I can solve what L is, because L is the same thing as X. So I know that L √2 equals 12 because that's the hypotenuse. So now I'm going to go ahead and solve this equation for L. So I divide by the square root of 2. That cancels. So I know that L equals 12 divided by √2. But it is improper for us to have a radical on the bottom, a square root on the bottom. So to get rid of it, I multiply by √2 on top and on the bottom. What that's going to do is it's going to give me a 12 √2 on top, 12 times √2. But on the bottom, I'm going to get √2 times √2, which again is √2 squared. And when you have √2 squared, it cancels with the square root, and you just have a 2 left. And now 12 divided by 2 is 6. So at the end of the day, I get that L equals 6 √2. And since X and L are the same, we know that X equals 6 √2. Alrighty, so that's our example number 2. So now we're going to have you try these 2 little guys. And then we're going to go to the second type of special triangle. And this is going to be the 30, 60, 90. So like before, I want to derive for you, if you will, kind of prove to you where this comes from. So supposing you had an equilateral triangle, ABC, an equilateral triangle, and then you draw in the altitude or the height, right? And of course, the altitude of an equilateral triangle is also the perpendicular bisector. And again, we learned that a long time ago. That makes this a 90-degree angle. And in an equilateral triangle, all of the angles are 60 degrees. So angle A is 60, angle B is 60 combined, and angle C is 60. But when you draw in the altitude, because it's the perpendicular bisector, it cuts that angle in half. So you get 2 equal angles of 30 degrees apiece. And that's basically how you get the 30, 60, 90 triangle formed. You'll notice that I made this half of the triangle dashed because that's not really part of the diagram that we're interested in. But I will tell you that for the sake of making this easy for us, I've indicated that the length of here to here is x, which would mean that the entire length would be twice that, because again it cuts it in half, so that means that these both are the same. So that's x and this is x, so x plus x would be 2x. So this entire length is 2x, and since this is an equilateral triangle, it would also be equiangular. Equilateral means that all sides are the same, so this length here is 2x, this length here is 2x. But again, we don't need this side of the triangle anymore, so I'm going to go ahead and erase it now. And we're going to be left with only the portion of the triangle that interests us in this whole 36. I just wanted to show you where the 36 and 90 comes from and why we use x and 2x for those lengths. So now you know that, again, we can use the Pythagorean theorem to prove the relationships that are present in a 36 to 90 triangle. And again, these relationships only apply if the triangle is a right triangle that's 36 to 90. So of course we learned before that the longest side is always opposite the biggest angle. So of course the hypotenuse being the longest is opposite the 90-degree angle. And then of course in this case the legs are not both the same like they were in the 45, 45, 90. So you have a short leg and a long leg, and the short leg is indicated here by x and it's opposite 30 degrees because 30 degrees is the smaller angle, so it would be opposite the short leg. 60 degrees is bigger, and therefore the long leg is opposite 60 degrees. That's important for you to note as well, to make sure that you have it set up correctly. So now I'm going to go ahead and call this altitude A. We have this distance here, the short leg is x, and the hypotenuse is 2x. So based on the Pythagorean theorem, we have leg, which is A. So leg squared, A squared. The other leg, x squared, equals the hypotenuse, 2x squared. So when I do this, I'm going to get a squared plus x squared equals 4x squared, because 2 squared is 4. So I want to show that you square both the 2 and the x. Now in an effort to combine like terms, I get that a squared equals 3x squared. And then if you want to solve, we're trying to solve for x here. We're going to get, hold on, I'm not sure if I want to solve for A. I want to solve for A, not for x, sorry. I want to solve for A, so I'm going to take the square root of both sides. And just like in the previous one, what we're going to do is we're going to split, that's going to be the square root of 3 times the square root of x squared. And again, in the case of the x squared, the square root and the square are going to cancel, and you're going to get A equals root 3x, or basically A equals x root 3. All right? And so that's basically what happens when you have this relationship. You're always going to get x root 3, and 2x. So we want to make sure that over here we write this as x root 3. Now I will tell you that because x is a variable that we use a lot in algebra and geometry, we don't want to use that variable for future reference. So a lot of times, like in your book, we'll call this s, 2s, and s root 3. It doesn't matter which variable you use. So we're just going to go ahead and be consistent with the book right now. And we're going to rewrite those. I'll do it in a different color here. Let's do it in this color. So we're going to call this S, 2S, and S root 3. So again, what I want to show you here, and I'm going to write it again over here on the side because honestly, the 45 line doesn't cause anybody a lot of problems. It's usually the 36 to 90 that causes people problems. So I just want to remind you that when you set up your problems, you want to be opposite 30 degrees, okay, is going to be the short side. So opposite 30 degrees is always going to be S. Opposite 60 degrees is the long leg, and that's always going to be s root 3. And then the hypotenuse is always going to be 2s. All right, so those are basically the formulas that you want, the relationship that you have with 30, 60, 90. Again, it only applies if you have a 30, 60, 90. So now we're going to go to our last example, and they're asking us to find both x and y. The first thing you want to do is determine whether you can apply 45, 45, 90, or 30, 60, 90. And we look at the triangle, and we know that this is 90. This is indicated as 60, which forces this angle to be 30. So we're going to apply the 30, 60, 90 rule. And like I said before, we know that when you are opposite 60, you're the long leg. Okay, so when you're opposite 60, you're the long leg, and you're always going to be s root 3. But at the same time, we can tell from the diagram that the long leg, s root 3, is supposed to equal 15. So s root 3 equals 15. All right, then we also have that opposite 30, which is the short leg, is right here. So opposite 30 is the side x. So we need to figure out what x is. And then, of course, opposite 90, the hypotenuse, is y. But, of course, in our formula, the hypotenuse is always 2s. So 2s equals y. So it turns out that x is equal to s, okay? So it looks like to me, what I want you to recognize here is that if I could figure out what s is, then I would have all of my answers, because I would just double it to get y, and s would be the same thing as x. And we don't know what s is yet, but we know that s root 3 equals 15. So all we have to do is come over here and solve this equation for s. So we divide by root 3, and you get that s equals 15 over root 3. But again, it's improper to have a radical on the bottom of the fraction. So you want to multiply top and bottom by root 3 over root 3, and you're going to get 15 root 3 on top. On the bottom, you're going to get root 3 times root 3, which is root 3 squared. And like before, the square root are going to cancel, and you're going to end up with 15 root 3 divided by 3. But 3 goes into 15 evenly 5 times. So in the end, we can finally say that s equals 5 root 3. Now, since s equals 5 root 3, that means that x equals s. So x equals 5 root 3. And then we know that the y value, the hypotenuse, is 2 times s. So y is going to equal 2 times 5 root 3, or basically 10 root 3. So y is 10 root 3, and x is 5 root 3. And that's how you apply the 30, 60, 90 to those little guys. Alrighty, so now you're going to try this last do-it-yourself question, and once you've completed this do-it-yourself question, you will have completed your notes for this lesson, and I will see you in class, and thanks for watching.